I'm walking through solutions for every algebra question on the SAT. This is part 10 about systems of two linear equations in two variables. These will be all of the easy questions from the SAT online question bank. Every question in this video will be 1 out of 3 difficulty, that's why it's easy, and they're all under the domain algebra and the skill systems of two linear equations in two variables. You can think of that as just systems of equations, and they're all linear. Hiro and Sophia purchased shirts and pants from a store. The price of each shirt purchased was the same, and the price of each pair of pants purchased was the same. Hiro purchased 4 shirts and 2 pairs of pants. You can say 4S and 2 pairs of pants for $86. Sophia purchased, we have 3 shirts, so it's 3S, and 5 pairs of pants, let's call that 5P, and that was $166. Which of the following systems of linear equations represents the situation if X represents the price in dollars of each shirt? So that's what I wrote as S, so we'll just change these to X's. And Y represents the price in dollars of each pair of pants. So I wrote those as P's, so we'll change them to Y's. So it should be 4X plus 2Y equals 86, and 3X plus 5Y equals 166. All right, so you're multiplying the price by the number of those items that you bought, and then you add up the number of shirts times the price per shirt, plus the number of pairs of pants times the price per pair of pants, and that will give you the total cost of that purchase. All right, so we want something like that, and it looks like 4X plus 2Y equals 86. The top one is correct, and 3X plus 5Y equals 166. That is also correct. So A is the correct answer. If we want to roll them out, they switched the 3 and the 2 here. That's why that one's wrong. They switched the 3 and the 2 here as well, and they switched the prices. And then here they just switched the prices. 5x equals 15 minus 4x plus y equals -2. Oh wait, is this 2 different equations? Okay, well they do this sometimes. I would assume on the real test they'll format it better than they're showing up on here. These are just the downloaded PDFs from the SAT Online Question Bank. But I believe this is supposed to be 2 separate equations like that, where we have 5x equals 15, and then -4x plus y equals -2, because they said the solution to the given system of equations, that implies that there's 2 equations at least, so it's not, right, this one thing equals this. The solution to the given system of equations is x comma y. What is the value of x plus y? Well, we'll start with this 5x equals 15. That already has only one variable, so we can just solve it directly. And we'll divide both sides by 5. That gives us that x is equal to 3. So 3 is the x coordinate of this ordered pair for the solution. And now we can use that 3 to find what y is, because we'll just plug 3 in for x in the other equation. We have 4 times, instead of x, will be 4 times 3. And that was -4, sorry. -4 times 3 plus y equals -2. Now we, again, just have one variable y, so we can solve it. -4 times 3 is -12. So -12 plus y equals -2. To get the y alone, I'm going to add 12 to both sides, which means that y will be -2 plus 12, which is 10. All right, so we have 3 comma 10 for our ordered pair, and they say, what is the value of x plus y? So we're doing 3 plus 10, which gives us 13. That would be C. The graph of the system of linear equations is shown. What is the solution x comma y to this system? So the 2 lines, one of them is this line that has a positive slope going up like that. The other one is at y equals 3. It's this horizontal line right there, slope 0. But the solution is just where the 2 lines cross, and that would be this point, which is 2 over and 3 up. So 2 comma 3, that's option C. Y equals 12x minus 20, and I believe this is going to be a separate equation. Again, they're really poorly formatted on here because it looks like it just says 12x minus 20y. On the real test, I really would hope they would make it look like this, minus 20, and then y equals 28 as 2 separate lines. What is the solution x comma y to the given system of equations? If this is what they mean, which I assume it is, then they already gave us that y is 28. So we actually know it's going to be either A or B. Y equals 28. So every point that's on this line, it's a horizontal line at 28 up from the origin. The only way that it's going to be on that line is if y equals 28. So it's either A or B. And then you just plug in 28 for y and then solve for x in the other equation. So you'd say 28 equals 12x minus 20. And then we're just getting the x alone, so we'll add 20 to both sides. Gives us that 48 equals 12x. You can think what times 12 makes 48, that'd be 4. Or divide both sides by 12, that's the opposite of times 12, to get rid of the 12 times x, and then we're left with x is equal to 4. All right, so we have 4 for our x-coordinate. They said 28 is the y-coordinate, so it's 4 comma 28, which is option A. A petting zoo sells 2 types of tickets. The standard ticket for admission only costs $5. Right, so it's $5 for that ticket. And the premium ticket, which includes admission and food to give to the animals, costs $12. So premium is $12. One Saturday, the petting zoo sold a total of 250 tickets and collected a total of $2,300 from ticket sales. Which of the following systems of equations can be used to find the number of standard tickets S, so that goes with the $5, and premium tickets P, that would go with the $12 on that Saturday? All right, so we have 2 equations. One of them has to do with the number of tickets sold, which in that case, the prices don't matter. You're just adding up the number of tickets. So S is the number of standard tickets. You're adding that with P, the number of premium tickets. And again, that gives you the total number of tickets, which is 250. The other equation will use the prices. That's giving the revenue. So they made $2,300. They make $5 for every standard ticket that's sold. So you do $5 times the number of standard tickets. That's all of the money from standard tickets. And then we'd have 12 times P. That's $12 per premium ticket times the number of premium tickets. That's all of the money made from premium tickets. So these 2 equations in some form should be the answer. And if we look, S plus P equals 250, so that checks out. 5S plus 12P equals 2,300. Choice A is correct. We want to look at the other ones. They had the first equation right, but they switched the prices. So they did the price of the standard ticket, they put that as the coefficient on P, and they put the price for the premium ticket as the coefficient for S. That's incorrect. Here, they multiplied the 5 and the 12 in the first equation, not the second one. Remember, 250 is just the number of tickets. So you shouldn't be multiplying by the price there. The price is not a factor in the number of tickets. It's just adding up S and P. So they basically switched to the left sides of these. And then down here, they still had it wrong where they're multiplying the prices, but they also multiplied the wrong prices. So D is just wrong for a lot of reasons. A is the correct answer there. All right, again, they're formatting these poorly. It looks like there's a space between that 4 and that x. It looks like it says y equals 4x, but it's supposed to be y equals 4 and x equals y plus 6. And they say the solution to the given system of equations is x comma y. What is the value of x? All right, well, they gave us y as 4, so we'll just plug that 4 in for the y for the other equation. If x equals 4 plus 6, 4 plus 6 is 10. So it's that simple, just adding 4 and 6, but just make sure that you can tell where where one equation starts and the other one ends. The graph of a system of linear equations is shown. What is the solution x comma y to the system? So one of them is this line that has this positive slope that is colored in pink. The other one is this line I'm coloring in green that is this negative slope. The solution is just where they cross, so it's this point right there where they intersect. So it's 3 to the right and 4 up, so you'd write that as 3 comma 4. Right? The x value is 3, the y value is 4. That is option B. X plus y equals 18, and then 5y equals x. I'm just putting that line to separate the two equations. They should be writing it as two different lines, like this and like this, but hopefully on the actual test that shows up, they'll have fixed that formatting issue. So what is the solution? X comma y to this given system of equations, they're giving us x is equal to 5y. So this is the first one where we actually have to use substitution or elimination in the normal context. So they're not just giving us the value of one of them and then we're plugging in, because the previous questions they were either saying y equals 3 or x equals whatever. But in this case, we have to substitute in a value in terms of the other variable. So since they gave x alone already, what I'm going to do, and we have to solve for x and y, I'm going to substitute in 5y in place of the x, because we know x is equal to 5y. So I'll write, instead of x plus y, I'm going to write 5y plus y equals 18. This is substitution. And then we have 5y plus y. You have 5 y's, you add another y, you have 6 y's. That's equal to 18. You think what times 6 makes 18? That'd be 3, or divide both sides by 6, and y equals 3. So actually, without even finding x, we know the answer is going to be A, because it's the only one that has 3 for the y coordinate. But just to confirm it, I think it's worth plugging it in. They say x is equal to 5 times y, so x equals 5 times 3, and 5 times 3 is 15. So x equals 15. If we wrote this out as an ordered pair, it'd be 15, right? The x-coordinate, comma the y-coordinate, 15, comma 3, which is choice A. Here we have x equals 10, and I don't think that's supposed to be 10y, so let's draw this line to separate them. We have x equals 10 and y equals x plus 21 as our two equations. The solution to the given system of equations is x comma y. What is the value of y? So we just want the y-coordinate here. They gave us the x-coordinate already. They said x is 10, so I'm just going to plug in that 10 for the x here. Now I said we haven't done substitution yet because we've done ones like this. You could argue this is substituting 10 in place of the x, but I more just think of this as plugging in the value that they gave us. So y equals 10 plus 21. In principle, it's the same as substitution, but just substitution is generally, I think of that strategy as you're plugging in this variable in terms of the other one. So like if we look at the previous question, we're plugging in y's, so then we had only y's left, not plugging in a value, but you do the same steps. Here we have y equals 10 plus 21, and 10 plus 21 is 31, so y is just 31. Y equals 2x plus 3, x equals 1. So this is properly formatted. You can see where one equation ends and the next one starts. What is the solution, x comma y, to the given system of equations? All right, well, we know that x is 1, so we can already eliminate c and d because it has an x value of 1. Right, this is a vertical line at 1 over from the y-axis. So all of the points on here will have an x value of 1. And then 2x plus 3, so we're up 3. And it's going up 2 over 1 like that. Right, so you could just go, okay, it's going to be 2 higher than that, so it's going to be this point at 1 comma 5, which is b. But I'm going to show how to do it algebraically. I was just doing a quick graphical solution. We would just plug in this value of 1 for x. We'd say y equals 2 times 1 in place of the x plus 3. 2 plus 3 gives us 5. So y equals 5, and then you'd write x comma y. So our x value is 1, our y value is 5. 1 comma 5, which is choice B. A system of two linear equations is graphed in the xy plane below. Which of the following points is the solution to the system of equations? So we just want to find this point where these two cross. You can see it's 3 over and 9 up. So that would be 3 comma 9, right? You write the x-coordinate comma the y-coordinate, and that is point A. 4x equals 20 minus 3x. Oh no, these are two separate equations. This one's really poorly formatted, but you can see there's a little bit more space between the 20 and the negative sign, or the subtraction sign. Although it's actually about the same amount of space that you have there. Anyway, what they mean for this to be is 4x equals 20 and negative 3x plus y equals negative 7. The solution to the given system of equations is x comma y. What is the value of x plus y? So we need to find both. So using this 4x equals 20, we can quickly solve what x is. Just divide both sides by 4. And we get that x is equal to 20 divided by 4 is 5. So if x is 5, then we can plug in that 5 for the x in the second equation. That gives us that negative 3, instead of times x, will be times 5 plus y equals negative 7. Negative 3 times 5 is negative 15. So negative 15 plus y equals negative 7. To get the y alone, I'm going to add 15 to both sides, the opposite of subtracting 15 or adding a negative 15. So it cancels here. We get y is equal to 8, negative 7 plus 15. So if we write out the ordered pair, that would be 5 comma 8. That's not what we're looking for here, though. They want the sum of x and y. So we're going to add up 5 and 8, which gives us 13. That would be choice C. Y equals 4x minus 9 and y equals 19. What is the solution, x comma y, to the given system of equations? So we just plug in 19 for y in the first equation, because they gave it to us there. And also we know it's not going to be c or d because the y-coordinate should be 19. We get 19 equals 4x minus 9. We just have to solve for x, so get the x alone. I'm going to add 9 to both sides, which gives us 28 equals 4x. And then you can think what times 4 is 28, which is 7, or just divide both sides by 4, the opposite of times 4, which will give us that x is equal to 7. So we have x is 7, y is 19, they gave us that, so it's 7 comma 19, which is choice B. All right, here it's another one that's poorly formatted, but I believe this is supposed to be x equals 5 for the first equation, and the second equation is y equals x minus 8. Which of the following points, x comma y, is the solution to the given system of equations in the xy plane? So we're just going to plug in the 5 for the x in the second equation. Get y equals 5 minus 8, and that's going to be a negative number. It will be y equals negative 3. So our x coordinate is 5, our y is negative 3. If we write that out, it's 5 comma negative 3. Put the x comma the y, which is option B. All right, this equation, this is another one that the formatting is really kind of confusing, but it's supposed to be 3x equals 12 and negative 3x plus y equals negative 6 for our two equations. If it's a system of equations, it should be two separate things. So the solution to the given system of equations is x comma y. What is the value of y? All right, well, we can quickly find the x. We have 3x equals 12, so we just divide both sides by 3. Gives us that x is equal to 4. And then using that 4, we can solve for y by plugging the 4 in for x in the second equation. That gives us negative 3 times 4 plus y equals negative 6. Negative 3 times 4 is negative 12. So negative 12 plus y equals negative 6. And you can think, what do you have to add to negative 12 to make it negative 6? That would be 6. Or just do the opposite of minus 12 or plus negative 12 is adding positive 12 to both sides. We get y equals 6. And then we have 4 comma 6. Or they were asking for the value of y. So all we need is that 6, which is choice B. Connor has C dollars and Maria has M dollars. Connor has 4 times as many dollars as Maria. So that means Connor's money is equal to Maria's money times 4, right? It's 4 times what Maria has. So Connor's money equals 4 times Maria's money. You can write that as C equals 4M with the variables they gave us. And together they have a total of $25. So when you add up Connor's money and Maria's money, they have $25. Which system of equations represents this situation? So it should be something like this. You could change the order, right? You could do 4M equals C or 25 equals C plus M or something like that. But let's see if we have something equivalent. So C equals 4M and then C plus M equals 25. It's interesting. So far, all of the ones where they've had us write a system of equations from the situation, option A has been the correct answer. I don't think that's going to be a thing on the real SAT, but I don't know if whoever made the online question bank questions forgot to reorder them or something. But here we have M equals 4C, so don't do that. Even though C is the bigger thing, some people's instincts will be, oh, you have to multiply the bigger thing. No, think of it, you want to make them equal. If C is 4 times bigger than M, then you have to have more of the smaller one. So M is a smaller amount of money, but you need to multiply that by a number bigger than 1 to make it equal to something that's bigger than it. Right? So you have to multiply you have to multiply the smaller number by 4 to make it equal to the bigger number. Right? That's why that one's wrong. And then C equals 25M. So yeah, the 25 is supposed to be for the total money they have when you add them up, not what you have to multiply. So it's not that. Same thing here. And they also switched the variables. X equals 4, y equals 5 minus x. So these are supposed to be two different equations. The solution to the given system of equations is x comma y. What is the value of y? All right, well, they gave us that x equals 4. So we can plug that 4 in for x in the second equation. Get y equals 5 minus, and then put in 4 for x. 5 minus 4 is just 1. So y equals 1. That will be option A. A dance teacher ordered outfits for students for a dance recital. Outfits for boys cost $26, and outfits for girls cost $35. The dance teacher ordered a total of 28 outfits. So let's say they're probably going to give us variables, B and G. So B is the number of boy outfits, and G is the number of girl outfits. If you add them up, that's going to be the total number of outfits, which they say was 28 outfits. So if you just add up the number of outfits not carrying that cost, it adds up to 28. And the teacher spent $881. So each boy outfit cost 26. We could do 26 times the number of boy outfits, and then that would be the total money spent on boy outfits. And then we've got $35 for the girl outfit. So $35 times the number of girl outfits is the total money spent on girl outfits. If you add the total money spent on boy outfits plus the total money spent on girl outfits, it would add up to the total money spent, which was $881. All right, so these should be our two equations. If B represents the number of outfits the dance teacher ordered for boys, and G represents the number of outfits the dance teacher ordered for girls, which of the following system of equations can be solved to find B and G? All right, so it should be similar to the ones that we wrote mean, they could have reordered it G plus B or 35G plus 26B. That doesn't matter because it's the commutative property of addition. But let's check. So here they're adding the prices, like they're factoring in the cost of them and then adding up the costs to make the number of outfits. That doesn't make sense. Right? The number of outfits is just adding up the number of boy outfits plus the number of girl outfits. The cost does not play into the number of outfits. Here, okay, they switched the order here, so this might be right. 26B plus 35G, that's the total cost, equals 881, so that's good. And then B plus G equals 28. So they just switched the order, doesn't matter. They kept each equation the same. So they wrote this equation first, then this equation. That's perfect. Let's just see why these ones are wrong. So this thing they also did, this one they changed the variables. So they multiplied the price of the boy outfits times the number of girl outfits, and they had them add up to 28. So this is just wrong in two ways. And then here they again switch the variables. They do have the numbers in the right place now, but it's just the fact that 26 should be multiplied. 26 is the price for the boy outfits, so that should be multiplied by the number of boy outfits, and 35 should be multiplied by the number of girl outfits at the cost of the girl outfits. It's the error with D. So B is the correct answer here. Finally, they had one where A was not the correct answer, so maybe they didn't make as many mistakes as they thought. They just happened to be concentrated at the top. The graph of a system of linear equations is shown. What is the solution x comma y to the system? All right, well, the solution is just where these two lines cross, where they intersect, which is 2 over and 4 up. So we write that as 2 comma 4. That is choice B. All right, let's see. I think this equation ends here after the 27. So we have s plus 7r equals 27. And then our second equation is that r is equal to 3. So what is the solution r comma s to this given system of equations? So we know it has to be, it's where the two lines would intersect. So it's a value of r and s that will work for both equations. The only value of r that will work for the second equation is when r is 3, because that's what it is. It's literally just, I mean, it's not x or y, so you can't tell for sure if it's a horizontal or vertical line unless you draw the axes and label one of them r. But this will be any point where r is 3 is on this line. So we could plug in 3 for r in the second one, or actually it's the first equation, which is s plus 7r equals 27. We're going to make that s plus 7 times 3, again, we're substituting 3 in the value of r, equals 27. And 3 times 7 is 21. So s plus 21 equals 27. You think what plus 21 makes 27? So s is 6, or just subtract 21 from both sides, and that will give you, again, s is equal to 6. So we need to find the value of r comma s. So I guess r kind of is in place of the x here. But r will be 3, and s will be 6. So 3 comma 6 is our answer. Just read carefully there. I mean, that's the order that they appear in the alphabet, so it makes sense. But they could have asked what's s comma r, and then it would have been a. So just read closely what they're looking for. X equals 8 is one equation, and x plus 3y equals 26 is the other equation. The solution to the given system of equations is x comma y. What is the value of y? All right, so we're just trying to find the y coordinate of this point that's a solution to both of them. And we know x has to be 8. Those are the only points that appear on that horizontal or that vertical line, x equals 8. And we'll just plug in 8 as the value of x in the second equation, and we get 8 plus 3y equals 26. Now we just have to solve for y. So I'll subtract 8 from both sides. We get 3y equals 26 minus 8 is 18. And then you can think what times 3 makes 18? Y is going to be 6. Or just divide both sides by 3 if that's what you're more comfortable with, and you get y is equal to 6. So all we're doing here is the value of y. 6 will be our answer. Let me actually rewrite that so it doesn't look like negative 6. All right, there we go. X plus y equals, what is this, 20 to the 2 times x plus y plus 3y equals 85. No, I think those are supposed to be two separate equations. This formatting is even arguably worse than the other ones. Yeah, I'm pretty sure, like, as the font changes here, I thought that the font changed to make this an exponent. It's not an exponent, I believe. Hopefully, really on the real test, I doubt that they'll have these errors remaining with the formatting. But x plus y should be 20, and 2 times x plus y, close parentheses, or 2 times the quantity x plus y, close parentheses, plus 3y equals 85. All right, so the first equation, we just have x plus y. That will probably be, if we're going to do substitution, the easier way to do that. And then for this next one, I'm going to use the distributive property first. That gives us 2x plus 2y plus 3y equals 85. Now we can combine our like terms of 2y and 3y, which will add up to 5y. So we get 2x plus 5y equals 85. All right, so here are our two equations. Now, if you want to do substitution, you would just get one of these variables alone. So we're trying to find the value of y. If all you care about is finding the value of y, you could solve for x in this first equation by getting the x alone. Basically, we subtract y from both sides, and we get x is equal to 20 minus y. And then in place of the x in this second equation, we're going to substitute something equivalent to x, which is this 20 minus y. I'm putting it in parentheses, so the whole thing is being multiplied by 2, because the entire x is being multiplied by 2, not just the beginning of it. So if I rewrite this with the substitution there, it'd be 2 times, parentheses, 20 minus y, close parentheses, plus 5y equals 85. Now, if I distribute this, 2 times 20 is 40, 2 times negative y is minus 2y, plus 5y equals 85. And now we can combine our y's, negative 2y, positive 5y gives you positive 3y. So we get 40 plus 3y equals 85. And now I'd subtract 40 from both sides, leaving us with 3y is equal to 45. Then you can think, what times 3 makes 45? That'd be 15. Or just divide both sides by 3, and y will be 15. All right, so you could just do it that way. You don't need to find x. If you wanted to find x, you would just plug it back in here, this original equation, x plus 15 equals 20, so x equals 5. And then to check it, you could plug both of those back in to the first equation, see if it, or the second equation, see if it works. So 2 times, we said it was 5 and 15, right? So 2 times 5 plus 15 plus 3 times 15 equals 85. We'd get 5 plus 15 is 20, 2 times 20 is 40. 40 plus 3 times 15 would be 45. 40 plus 45 is in fact 85. So 85 equals 85, that checks out. Now the other way you could do it, you could just plug these both into a calculator and just see where they cross, because it is calculator active. Now, if you have a calculator that needs it to be in y equals form, that would involve some level of manipulation of the variables to get the y's alone, which, just be careful with that. Make sure you don't mess up, lose a sign anywhere, anything like that. The other way you could have done this is, instead of substituting, you could have done elimination. So I'm just going to show that really quickly in case anyone feels more comfortable doing elimination. In this case, I might have done elimination. So first, once you have this equation simplified, those steps would be the same. You have 2x plus 5y equals 85. Right? We used the distributive property, distributed that 2, combined our like terms. We got this from the second equation. And the first equation they gave us was x plus y equals 20. So for elimination, you would choose which variable you want to eliminate. And for solving for y, you want to eliminate x. So I'm going to multiply this first equation, this x plus y equals 20. I'm going to multiply every term by negative 2. You think of it as multiplying the entire thing by negative 2. The reason we're doing that is because we have a 2x in the second equation. We want to get rid of the x's. So if you multiply x by negative 2, you're left with negative 2x, which when added with 2x will cancel out, right? It will add up to 0. So negative 2 times x is negative 2x. Negative 2 times positive y is negative 2y. And then negative 2 times 20 will be negative 40. Right, now we can just add the two equations. So add the left side of each equation and then add the right side of each equation. And since they're equivalent, right, you're adding the same thing to both sides. So we get 2x minus 2x is 0. 5y minus 2y will be 3y. And then 85 minus 40 will give you 45. 85 plus negative 40, you'd say it like that. So that gives us that 3y equals 45. Then just divide both sides by 3. It gives us that y is equal to 15. Right, so that was actually faster, and that's why I would have done elimination in this case, because they're already lined up in a way where they both have an x plus a y. You just have to multiply. The only thing you had to do is multiply this by negative 2. But I think probably substitution is considered the easier method in terms of it's more straightforward. It's usually the method that you learn first. But if you're comfortable with both, in this case, as long as you are equally comfortable with both, elimination is the easier method in terms of its fewer steps and less algebra that you need to get from the elimination step to your final answer, which was 15. You can see there are more steps here by, maybe a matter of like 2 steps or something. Y equals negative 3x is our first equation. Again, they have the formatting kind of lousily done, but then 4x plus y equals 15. The solution to the given system of equations is x comma y. What is the value of x? I think this might be the first one they're asking for just x. They're usually asking for x and y or just y. But they gave us that y equals negative 3x. So this one will be one that I'll do substitution. They have the y alone in terms of x. And then our second equation, 4x plus y equals 15. We want to solve for x. So if you substitute in negative 3x in place of that y, then you'll have only x's. We can solve for x. That will give us that 4x plus, again, instead of y, it's going to be negative 3x is equal to 15. And plus and negative is just the same as minus, so you could write this as like 4x minus 3x equals 15. If you have 4x's, get rid of 3 of them, then you only have 1 left, so it's just x is equal to 15. And then if you had to solve for y, they don't. In this case, you just plug in that 15 for x, so negative 3 times 15 gives you y equals negative 45. You want to check that. Another way you can check it, once you have that it's 15 and negative 45, I always tell my students on a system of equations problem, you should know, like you can check, as long as you have a calculator, it's really easy to check that your answer is right. Plug in x and y in both equations and they should work. So we'd say 4 times 15 plus negative 45 should be equal to 15. 4 times 15 is 60. 60 minus 45 is in fact equal to 15. So that checks out. The graph of a system of linear equations is shown. The solution to the system is x comma y. What is the value of x? All right, well, the solution is where they cross at this point right here, which is 4 comma 1, right? It's 4 over 1 up. They want the x value, so just the 4. The graph of a system of two linear equations is shown. What is the value of x comma y to the system? So just where they cross, that's this point, that's 2 over 2 up, so it's 2 comma 2, which is choice B. We have two equations, 3x plus y equals 29 and x equals 2. If x comma y is the solution to the given system of equations, what is the value of y? All right, well, we know x is 2, because it's the only point that will work for this line, x equals 2. So we can plug in that 2 for the x in the first equation. So we get, instead of 3 times x, it'll be 3 times 2 plus y is equal to 29. And now we just have to solve for y, get the y alone. So we get 3 times 2 is 6, 6 plus y equals 29. Think what plus 6 makes 29, which would be 23. Or just subtract 6 from both sides, and y will be 29 minus 6 is 23. Right, so what is the value of y? That's all we're solving for is 23. The graph of a system of linear equations is shown. What is the solution x comma y to the system? So the solution will just be where these two lines cross, or where they intersect, where they meet as well. That'd be 4 over and 5 down. So we'd write that as 4 comma negative 5. And that's what they're looking for, is just that ordered pair. So it'll be A, 4 comma negative 5. An online bookstore sells novels and magazines. Each novel sells for $4, and each magazine sells for $1. If Sadie purchased a total of 11 novels and magazines, so that would mean, let's say we're doing the number of novels as n, and the number of magazines as m, n plus m, the sum of the two, would add up to the total number of novels and magazines of 11. And they had a combined selling price of $20. Well, if you wanted to find the selling price of all the novels you get, that's the number of novels, n, times the price per novel, so times 4. 4 times n is the price for all of those novels that were bought. And then 1 times m will be the price per magazine times the number of magazines, which you can also just write that as m. 1 times m is just m. So 4n plus m will account for the prices as well, and that adds up to $20. All right, so we've got these two equations. How many novels did she purchase? All right, so this is one where you don't just have to write the equations, you have to actually solve for it. But they made it pretty nice, because the price of the magazines being 1 means that you've got 1 here, or 1m here and 1m here, and we're solving for the number of novels, so we need to solve for n. So what we can do is just multiply this first equation, the n plus m equals 11, multiply every term by negative 1. Or you think of it as dividing it by negative 1, it's the same thing. That will give you negative n minus m is equal to negative 11. Now, some people will just say, oh, just subtract this first equation from the second equation. I think it's better to always treat it as you're adding the equations and multiply by a negative if you want to cancel something out. The reason, again, we're doing this is because we've got 1m here, and we're adding a negative m, which will cancel out the m's, leaving us with only n's. You can't solve for a variable in an equation if there are multiple variables, like multiple variables appearing. So just from 4n plus m equals 20, we can't solve for n as a number because we would get it in terms of m's. But if you only have one variable, then you can solve that equation. So in this case, 4n minus n gives us 3n. You can think of it 4n plus negative n. And then m plus negative m would give you 0, so it would cancel out. And then 20 plus negative 11 would give you 9. So 3 times n is equal to 9. And then you just divide both sides by 3. And it gives us that n is equal to 3. Or you think 3 times 3 makes 9. Now, if you want to check this, just plug it back in. You can figure out what m is. So if n plus m equals 11 and n is 3, that means 3 plus m equals 11. So m is 8. And then plug it into the other equation. 4 times 3 plus 8 equals 20. 4 times 3 is 12. 12 plus 8 is, in fact, 20. So that checks out. Now, this would be how you would do it algebraically. You could also, once you have your two equations, you could graph them and then see where they intersect if you want to use your graphing calculator. Or one thing that some people would do, and this is not what I would recommend, but this is how you could do it even if you didn't know substitution and elimination. You could also have done substitution, but that'd be a little bit more tedious in this case for no reason. But one thing you could do is you could realize, all right, well, n plus m is 11. Now, if they both cost $1, then the total cost would be $11 because each one would be $1, $1. We are $9 more than that, right? So it's $9 more than $11. Now, that extra cost can't be coming from magazines because the magazines do cost $1. That means that the extra cost is coming from the novels. And one novel costs $3 more than one magazine, right? $4 is 3 more than 1. So that means that you have a certain number of novels where anytime you get a novel instead of a magazine, you're adding 3 to the total cost. So how many times would you have to switch a magazine to a novel? That would be 3 times, right? Because 3 times 3 would give you 9. So you could think of it that way. I really would just recommend doing elimination in this case and then maybe plugging in to find m and then plug in n and m into the second equation to make sure that it checks out, right? This is just done to check because all we needed was the n value there. And again, n equals 3, that would be option B. The graph of a system of linear equations is shown. What is the value of x comma y to this system? All right, so we just need to see where they cross. The intersection point is the solution to these two equations. And then the coordinates for that would be -4, -3. It's 4 to the left, 3 down. So you'd write that as the x coordinate, -4, the y coordinate, -3, and that is option C. A discount airline sells a certain number of tickets, X, for flights for $90 each. It sells the number of remaining tickets, Y, for $250 each. For a particular flight, the airline sold 120 tickets and collected a total of $27,600 from the sale of those tickets. All right, so the total number of tickets is 120, and we have X number of tickets that are the discount tickets, plus Y number of tickets, which are the expensive tickets. If you add up the number of tickets from the two types of tickets, that give you the total number of tickets, which we said was 120. So X plus Y should be 120. Now, if you want to do the cost of all of the discount tickets would be the cost per ticket, $90, times the number of tickets, that's the total cost of the discount tickets, plus, or cost I should say, like revenue from them, but right, the total sales of them. And then we've got Y is the number of the expensive tickets times 250. So 250Y will give you the total revenue or the total sales of the remaining tickets, right, the more expensive tickets. And that would add up to the total cost, which we said was $27,600. Right, so one equation is just the number of tickets with price not included. The second one is incorporating price so we can get the total revenue from it. Which system of equations represents this relationship between x and y? So we want something that's similar to these equations. And you could switch the order of the equations, or you could do the commutative property of addition and change. So it's y plus x instead of x plus y, but they have to have the essence of them staying intact. So here we have x plus y equals 120, so that's good. And then 90x plus 250y equals 27. 27,600. Okay, so A is correct. Those are the exact equations that we wrote. The next one, they have x plus y equals 120 is correct. And then over here, they're multiplying 120 times the, okay, so they're multiplying the number of tickets times the revenue that they got from all of the tickets. That would only work if instead of 27,600, they gave us the average revenue per ticket was this or something like that, which would be a weird number to give. But you don't multiply the number of tickets by the revenue that you got from all of those tickets. Right? That's not, doesn't make any sense. So B is wrong. X plus y equals 27,600. No, that would mean that you sold this many tickets. You did not. This is the money from the 120 tickets you sold. It's not that. They did the same thing where they're multiplying the 27,600. And then here, 90x equals 250y. That doesn't make any sense. Let's see. That would only make sense if they said you made an equal amount of revenue from the cheap tickets and from the more expensive tickets, which they say no such thing. And it's very likely not true. So that's not correct. And then 120x plus 120y. This would be if you bought 120 of each type of ticket, right? You only bought 90 of these tickets, and you only bought. No, this would be if both tickets cost $120, which this one costs 90 and this one costs 250. So this one's just wrong all around. A would be our correct answer there. A movie theater charges $11 for each full price ticket. So $11 for each full price ticket and $8.25 for each reduced price ticket. I guess it's probably for like a senior discount or a kid's discount. For one movie showing, the theater sold a total of 214 full price and reduced price tickets. All right, so do they say what variables we're using? F for full and R for reduced. I'm going to reread that anyway, but that means that F plus R is the total number of tickets, right? The number of full price tickets plus the number of reduced tickets. That would add up to the total number of tickets, which they said 214 tickets. And they reduced price tickets and the amount they made, so 4 is 2,145. So that's going to be the right side of the equation for the other equation, which has to do with the actual price. It says, which of the following systems of equations could be used to determine the number of full price tickets F and the number of reduced price tickets R sold? All right, so the full price tickets they said are 11. So if you want to make the revenue from the full price tickets, you do 11 times the number of those tickets. That's all revenue from full price tickets. Plus, and then the price per reduced ticket was $8.25. So 8.25 times the number of reduced tickets will give you the total revenue from reduced tickets. If you add those two up, it gives you the total revenue all around, which is $21.45. So these should be our two equations. And let's see, we've got F plus R equals 21.45. No, that would say that the number of tickets is 21.45. That's incorrect. And then down here, they did like the revenue being only 214. That's also incorrect. F plus R equals 214. Okay, so that's good. The number of tickets adds up to 214. And then 11 times F, okay, the revenue from the full price tickets, plus 825R, that's the revenue from the reduced tickets, adds up to that total revenue. So B is correct. Those are the same equations that we have. And then just let's rule out the other ones. F plus R equals 214. That part is right, but they have 825F. So they're doing the full price ticket being multiplied by the cost of the reduced ticket. And then right, the number of reduced tickets are being multiplied by the cost of the full price ticket. So they just switch the coefficients here. That would be the error with C. And then full plus R equals 21.45. So again, they're saying that they add up to a total of 21.45 number of tickets. That's incorrect. And then right, that they only made 214 in revenue. That's also incorrect. So B is the right answer there. Angela is playing a video game. In this game, players can score points only by collecting coins and stars. Each coin is worth C points and each star is worth S points. So let's do the coins are worth C points. The stars are worth S points. So it's the value of those things, the number of points. The first time she played, Angela scored 700 points and she collected 20 coins and 10 stars. So 700 points was equal to 20 times the number of coins, right? Because that's all the points you got from coins is the number of coins, 20 times the points per coin, C. And you're adding that with 10 stars, so 10 times the number of points per star, right? And that adds up to the 700. The second time she played, she scored 850 points, so it's the right side over here. And she collected 25 coins, so it's 25 times the points per coin. and 12 stars. So it'll be 12 times the number of points per star. All right, so the equations that we have should be something like this. It says, which system of equations can be used to correctly determine the values of C and S? All right, so just which equations are compatible to these ones that I wrote. We got 10C plus 20S. Now this one, they switched the coefficients. Right? It should be 20 coins and 10 stars, so A is wrong. Next, we have 20C plus 10S. Okay, that's good, equals 700. And 25C plus 12S equals 850. Okay, so that would be correct. Those are the same exact equations that I have. Now let's see what they messed up with C and D. 20C plus 700S. So 700 should be the total, and it should be 10 stars. They did this as if you got 700 stars, and when you add that with the 20 coins, it was only worth 10 points, so that's wrong. They did the same thing here. They switched the 12 and the 850. So C is wrong, and 700 here, they put the 700 as the coefficient in front of the coins, the 850 is the coefficient in front of the coins in the second equation. That's wrong. So it's just going to be B there. 20C plus 10S equals 700, and 25C plus 12S equals 850. Here we have 2x plus 7y equals 9, and 8x plus 28y equals a. So they have some constant there. In the given system of equations, a is a constant. If the system has infinitely many solutions, what is the value of a? Interesting. So to have infinitely many solutions, they would have to be the same exact line. Right? So think about like this would be your first line. I don't know if it actually is a positive slope like that. I think it's actually a negative slope because it would be, what is it? Negative 2/7 is the slope, so it's going down 2 over 7, whatever. But so if that was your first line, then if the second line is a different line like that, then they have 1 point that they cross. Even if they're both going down, right, they would just have 1 point that they cross. If they were parallel lines, then they would never cross, right? So they would have 0 solutions. But if this line happens to be the same line, then every point that's on this line would be a solution. It doesn't mean that any possible value of, or combination of x and y is a solution. Right? It's not like every point is a solution if there are infinitely many. It's just there are infinite points on the line, and any point on either line, because they're both the same line, would be a solution to both equations. So we need to find a way to make this equation equivalent to this equation. And we can see they have 2x plus 7y equals 9. The other one is 8x plus 28y equals, we don't know what it is. So this is an A. I know my A's sometimes look like 9s. But if you look closely, 2x, if you multiply that by 4, you get 8x. And 7y, if you multiply that by 4, you get 28y. So if we just scale this equation up by 4, and I say scale up, we're not dilating it or anything. We're not actually changing the equation. We're just multiplying every term by 4. If you do the same thing on both sides of the equation, it doesn't matter. It doesn't change the value. This would become 8x plus 28y equals 9 times 4, which would be 36. So if the a value here is 36, we still have this 8x plus 28y. If that was 36, then these are just the same equation. So our answer is choice C, 36. And if you want to check it, then after you've found this, so 8x plus 28y equals 36, type both equations into your calculator. The original equation, the 2x plus 7y equals 9, and then this one that we multiplied every term by 4, you'll see that it's just going to be one line showing up on there. And if you have one that traces over it as it goes, you'll see they are the same exact line, which means they have infinitely many solutions. And that is the end. All right, so those are all of the questions that are listed as easy difficulty under the scale systems of 2 linear equations in 2 variables. You saw that a lot of them were these ones where they gave you a graph of them and they just said, like, what's the x coordinate or the y coordinate, or what's the ordered pair for the solution, right? The solution to that system of equations. There you're just finding where they cross. Those are pretty straightforward. Just make sure you read closely. Are they looking for x or y or both? Some of them, they give you a word problem and you had to choose which option was correctly writing those as equations. So those ones, it takes a little bit of reading comprehension skill. I would practice doing those so you're comfortable with them and doing them quickly, but they're really not that bad. I think they only had 1 in this easy section where you actually had to solve it. Maybe it was 2. I assume more of the medium and hard ones will give you a word problem and then you also have to solve it. So, doing the practice with the easy ones, just setting up the equation first will be helpful. They had a few questions where substitution or elimination would help. They had a lot where one of the equations they gave you was y equals blank or x equals blank. So you didn't even have to do any algebra. You didn't even have to do any algebra to simplify that. You would just plug in the value they gave you for x or for y into the second equation, which, you can argue that is a form of substitution, but you're not actually using a difficult form of substitution as far as like what you would learn in more complicated algebra problems. But they had a couple where you had to maybe manipulate it a little bit. Like they'd say like 3x equals 6. You'd have to figure out that means that x equals 2. But they're all pretty straightforward here. And you can see there's a lot of these ones. The main thing that might be challenging is if you download the PDFs from the SAT online question bank like I did, sometimes the formatting is thrown off. So just, read it carefully. This at first looks like it's y equals negative 3x, 4x plus y. I mean, in this case, it would be a little more obvious, but some of them, they look like they're all like one equation with two sets of equal signs. So like this equals this equals this. That's not what they mean. On the real test, I very much assume that they would have that fixed. Or like this one was a little bit off, but you can see this had a different font than this. They just should have been separated more. And I think even if you go onto the online question bank, you can adjust it. Just if you download it as a PDF, they just will automatically format how they do. So be careful with that. And make sure you're comfortable using, even if it's not X and Y, that you can figure out what the order pair is. Just make sure you're keeping track of which one's R, which one's S. And overall, I really feel like these were probably not too challenging if you're familiar with systems of equations, if you've done, writing equations from word problems, and if you've done substitution and elimination before. But if you have any questions, or if you found any errors that I made, or if you had any recommendations, please comment those below. Any feedback is appreciated. And the medium and hard videos should hopefully be coming very soon for systems of two linear equations and two variables. Again, just think of it as systems of linear equations. The two variables usually would be kind of implied there, but this is how they would label it on the online SAT question bank. But anyway, thank you for watching, and those next videos should be coming soon.